So we carry on the chemical properties of alkanes. One very useful thing that is done in the oil refineries and from long ago now, that is cracking of alkanes. When fractional distillation of crude oil is obtained, larger alkanes, long chain alkanes are in abundance. Short chain alkanes, smaller alkanes, gas and petrol, which are in more demand in the market, they are less. Plus hydrogen gas is less, rare rather. Alkenes, carbon, double bond carbon compounds are less, which have numerous uses basically in the industry. These alkenes are basically the starting molecule for making all kind of plastics, petrochemicals, synthetic materials, so many things. So what is done? A process in which large long chain alkanes are cracked, broken, split down to small short chain alkanes, and by use of heat and catalyst. Catalysts are heated up around 400 to 800 degrees Celsius, they are heated up, and then the flood of alkanes is passed over their beds. Alkanes are cracked down, their chains are cut down, split down, and as a result short chain alkanes are obtained, which are later distilled again to obtain. But the byproducts are hydrogen and alkenes. Cracking, a very useful thing. We can take an example how it is done. Like a long chain alkane, we can take, suppose C18 CnH2n plus 2 should be 38 CnH2n plus 2, and when it is cracked, you may sometimes need to write down the catalyst, aluminum oxide somewhere, or an equation may write like this, and large alkane and the word Al2O3 written and this sign made mean heat. Instead of this catalyst Al2O3 high heat capacity, it may be sometime written pumice or porcelain pieces. A small piece is shown that shows that catalyst is there. So instead of a large chain alkane, sometime they write even the word paraffin because it's a large chain alkane molecule. You need to understand what they want to say. This is a larger alkane being subjected to a catalyst and it is heated up. Catalyst may be porcelain pieces, a pumice, ceramic, Al2O3. You need to understand this is cracking process going on. And when you crack, you need to produce small chain alkane and an alkene, or two alkenes and hydrogen, or alkanes and carbon and hydrogen, whatever you want. You need to satisfy this equation. Your product should contain 18 carbon atoms and 38 hydrogen atoms. To make things simple, make an alkane, an alkene, like C14H30, and left behind how many carbon atoms are there? 14, 15, 16, 17, 18, 4. So C4H8. So one alkane molecule and one CnH2n ene molecule, alkene molecule. When cracking is done and they are passed over the heated catalyst, all variety of products are obtained. You can write any equation, but sometimes if the examiner restrict you that one of the product is this, the other product you need to think looking at the number of carbon and hydrogen left. Or if he asks you to basically write down an equation that also yields hydrogen, in that case produce two alkenes, like it can go like this, C14H28 and C4H8 and hydrogen gas. Or depends on, it's easier way to write, you can write down also smaller products, but keeping in the count that C18H38 should be there. Sometimes you ask you what is the waste product of this. The waste product is carbon atoms. When they are heated too much, sometimes the splitting occurs at wrong places, carbon atoms, carbon soot. But the byproducts are alkene and hydrogen. That is why alkanes are basically cracked to produce smaller alkanes. And these smaller alkanes have more uses, petrol is in much demand, and gas, hydrogen gas is obtained, is utilized by ammonia industry for making fertilizers, and hydrogen gas for any other fuels. It is used as a fuel for rocket fuel, and alkenes, I said earlier, they are used for making plastics. So cracking, as the name indicate, it's a chemical reaction Because decomposition of the alkanes basically occur at different points of their long chain. Simply the long chain alkanes, less in use, they are cracked down, and when they are cracked down, smaller alkane like gas, like petrol, and some carbon atom. Always one essential product of cracking is, an MCQ may contain one essential product of cracking always is carbon, double bond carbon thing, alkene. Alkene is essential. It has to, because the chain is cracked, the carbon atom will settle in their valencies themselves. So alkene is always the compulsory product. But anyhow, cracking is just like you have a glass porcelain stuff, or it may be simple glass, and you throw it down into the hard thing, it's split into small pieces. It is cracking. Okay, simple. Any glassware, anything in your hand, you throw it down, it's split into smaller pieces. That's cracking. So depends on how much force you apply, the number of pieces. But the pieces will be containing basically everything out of the glass. Similarly, your cracking product should contain everything from what? Your alkane molecule. I mean, not a penny less or more. Carbon atoms should remain the same, hydrogen atoms should remain the same, and your chemical equation must be balanced. To make things easier, I said make an alkane and an alkene, or make two alkenes and hydrogen. But if it restricts you that this, when a particular molecule is cracked, one of the product is suppose propene, butene, make one butene and then the rest butane, rest whatever actually the carbon atoms are there. Okay, so cracking equation is needed. The catalyst is normally Al2O3 pumice or something, and conditions for cracking, if he asks, you will say catalyst must be present and heat. Condition. If he asks products, you say alkanes and alkenes and hydrogen. And if he asks what is the reason for cracking, you say we crack them down to obtain smaller alkanes like gas and petrol, more in demand, less pollution they create. And hydrogen gas and alkene obtained, which are having numerous uses. Okay, do practice alkane cracking equations. That's all from chemical reactions of alkanes.